Hi, this is Dr. Graves from the CSUN Geography Department and geographyplanet.org. This video tutorial is dedicated to instructing you how to calculate a t-test using Excel. A t-test is a way that you can tell the difference between two groups of data or two data sets, a sample of data, and it can be between an overall group of data, like the entire city and a specific neighborhood, or between perhaps two different neighborhoods. Are they the same, statistically the same, or are those differences statistically significant? And the third of those is sort of a before and after. Is the average different in time one versus time two? All three very useful in order to demonstrate or at least find out if the differences between two samples are significantly different. Now, without getting too much into the statistics, generally what you're testing for is whether or not to reject a null hypothesis. And basically the null hypothesis says there's no difference, or the difference isn't big enough to concern you, or it's not a significant difference. And in most of these instances, we're going to find that these differences are big enough to reject the null. We're going to say, something's very different about these groups, or something's very different from time A to time B. So let's go ahead and get started. So what you see before you is some data that I downloaded from the LA Police Department, and it contains the arrest data from 2015 to 2020. And to provide you with a little bit of extra practice with pivot tables, I'm going to show you how to derive our samples. So just click in here, insert pivot table, click OK, and that's going to create a new sheet. Okay, click over here to activate the pivot table tools, and what I want to do is grab several of these bits of data. The first thing that I'm going to grab is the descent code, and so that way we have these indications of the ethnicity of the people that have been arrested. And then I'm going to grab over here area name and put that underneath, and then that gives us the various divisions within the LAPD. And then let's grab a descent code over here and drag that into the values box, and that tells us how many people in total have been arrested. And so A is for say Asian, and B is for black, or this is one type of Asians. And then let's grab age and drag it down here. And we don't want the sum of age, but I'm changing the value here, the value field settings, to the average age. So let's click on that. What we also need to do is to change or reduce the data down to something more manageable. And so charge group description, I'm going to grab that and pull it here and into the filters, so we don't have these massive numbers. And I'll just take one from the top here. I want to select multiple items, clicked on that, and then just aggravated assault. That should give us plenty of data to work with. And also we will filter out the descent code. So I click here on row labels, and I don't want to select all. Let's just select B for black, H for Hispanic, O for other, and W is for white. And these are the major groups in Los Angeles, so we will have plenty of observations, a robust sample size for all of these groups. Okay, so the next thing I'm going to do, I'm just going to take the descent code and move it from the rows box to the columns box, and that way I have the data arranged in a way that's really quite convenient for copying it over to a new sheet. So I'm going to click on a new sheet here, and I'm just going to paste into a new sheet. The last thing that I'm going to do, I'm going to go back here, and I'm going to take the descent code completely out so that I have then the data for the entire group, regardless of ethnicity. I'm going to paste it over here in a completely new area. So Black, Hispanic, other, and white. I'm going to just insert some columns here to separate the data out a little bit so we can see what's going on. It is this data here in green that we will perform the t-test upon. We're going to do two different kinds of t-test. Maybe I'll put this one in blue or something, as it represents the entire community of people who've been arrested. But the question we're going to ask is this group of people, the first question we're going to ask is this data about the average age of people who have been arrested for assault who are Black, is it significantly different than the average age of this sample of people who have been arrested who are Hispanics? And we can compare Blacks and Hispanics. We can compare Blacks against others. We can compare Blacks against whites. And then what we'll do later is compare each of these groups against the overall sample of people who have been arrested in Los Angeles, regardless of their ethnic identification. There are several ways to go about doing a t-test. I would suggest that you click on the Data tab, click on Data Analysis, and from the data tools that are available to you, select the t-test. Now there are a couple of these available here, and the very first one we're going to use is the t-test to sample assuming unequal variances, which is almost always the case. We're going to assume that these groups of people are going to have different age structure in Los Angeles, so we should assume unequal variances. I'm going to click OK, and it's going to prompt me for the range. So the first group that we will compare are Black folks. We're going to make them variable range 1 against variable range 2, which will be Hispanics. We have a hypothesized mean difference. I'm just going to leave this as 0. But if, for example, we knew what the overall mean difference in age between Blacks and Hispanics were in Los Angeles, we could put that in there, and that may help us decide whether or not people who are arrested from one group are significantly different than those who are perhaps not arrested. We have included the label here at the top, Hispanic and Black, so we'll check that. And alpha is 0.05 is very standard in terms of statistics, and so we're basically saying we want a 95% confidence interval. And then the output range is where the little readout's going to happen, and we could put this on a new worksheet if you want, but I'm going to put it right here. It'll start, all I have to click on is where I want the upper left hand corner of the readout to appear, and I'm going to click OK. So what you see here is the mean for both of these groups, and we see that the average person who was arrested that was black for assault is 35.26 years old, and younger are the Hispanics who were arrested for the same thing. They have different variances, so that was correct that we assumed that. We don't need to really worry about this, but we assume that there was, our hypothesis said that there was no significant difference between those two. And so the big question is 35.26 really that different than 31? And our T statistic right here in pink tells us yes, it is, because that number, in order to achieve statistical significance, the critical value only had to be 1.70 if we were saying that one was significantly bigger than the other. We only needed to get to 1.70, and the two-tail says, is one different than the other? It's a slightly higher bar to leap, but this t-stat only had to be greater than 2.05. The probability is appearing here as a scientific notation. So let's go ahead and change that to number. And this is basically the chance that you would be wrong if you said those two are significantly different. And that's a lot of zeros. So you can say with a great deal of certainty that the average age of these two groups are statistically significant in their difference, and you would be able to reject the null. Okay, so I've repeated this test comparing black folks and white folks here, and we see the t-stat is now negative because the people who are arrested for assault who are black are much younger than the white people. According to the t-stat, when you compared black and Hispanic, it was the other way around. Black folks were much older than Hispanic who are arrested for the same thing. But still, the chance that they are the same is minuscule, very small, lots of zeros. Now, when you compare black folks against the other category, which was people of, I guess, unknown ethnicity, then that t-stat is negative 2.61. Black folks are a little bit younger than that category, but the t-stat is only 2.61, which is close to the critical t-stat for the two-tailed version of the test. And then with this, you get some chance that you could be wrong by saying that they are different. And now it's only a 1% chance, but if we had set our test to 0.01, then we could not say, if we had to be 99% certain, that we would not be able to reject the null. We would say there is a chance that these two samples are statistically similar enough that we couldn't really say that they're different. So that ends the first part of this video tutorial. The second part will replicate the t-test, but comparing the individual ethnic groups against the overall population. And we'll take a look at the paired t-test for sort of before and after testing with 2 years of data.